Assalamualaikum warahmatullahi wabarakatuh and good morning. Welcome to Immb International Webinar Series. And today we are honored to hosting visiting Professor Prof. Hyo-Bang from Hanyang University. He will share his talk regarding within and between person variability of urinary platelets and bisphenol over 7 days. Consideration of biomonitoring study design. A brief introduction about Prof. Hyo-Bang is a professor at the Department of Marine Science and Convergent Engineering, Hanyang University, Korea. He is an environmental analytical chemist with good knowledge in environmental chemistry, wildlife ecotoxicology, and human exposure to persistent organic pollutant and emerging contaminant. He got a PhD degree from Hyo-Bang National University in 2003 during 1999 to 2010. He had worked for the National Institute of Fisheries Science as research scientist. Since 1999, he has published over 230 peer-reviewed articles, which are related to marine pollution, bioaccumulation, analytical method development, biomonitoring, and human exposure to OPOPs and emerging contaminants. His current research project include an investigation on environmental fate and bioaccumulation process of POP and emerging contaminant in fresh or coastal waters. He was selected as a POP's review committee under the Stockholm Convention of the United Nations Environmental Programme during 2020 to 2024. He is serving as associate editors in Ecotoxicology and Environmental Safety and Frontiers in Marine Science, an editorial board member of Chemosphere, Bulletin of Environmental Contaminant and Toxicology, Journal of Emerging Contaminant, and several domestic journals. Without further ado, I welcome Prof. Hyo-Bang to present his talk. The floor is yours, Prof.
And this one, it's okay. Okay, thank you very much for your kind introduction. My name is Hyo-Bang. I'm now working for Hanyang University, South Korea. Before my presentation, I would like to express my appreciation to Dr. Hyo and Norita for inviting me. This is the second time to visit the UITM after the last year. So especially it is it's my pleasure to be some visiting professor in UITM. So we are discussing about what is suitable topics for promote your research and also to give some good insight for your research. So among my research topics, I considered about the human biomonitoring. So today I'm gonna talk about so within and between person variability of urinary phthalate and bisphenols over 7 days to give good insight to how to organize a biomonitoring program. So I believe you heard about the human biomonitoring. This is a very general, very simplified schematic diagram how to understand the human biomonitoring. So you can see here the human biomonitoring normally we are calling HPM. It's the same name, name of my abbreviation of my name, Hyo-Bang. Okay, so this is our body. If you expose any chemicals through the food, indoors, any product contact, the chemicals can be moved into our body by absorption processes. And then the chemicals can be distributed by the blood circulation. And the chemicals are like any specific tissues and organ, they can be deposited for a long time. We call the accumulation. However, some of our bodies want to depurate these chemicals. The kind of process we call the metabolism. And finally, they can be excreted from our bodies by urine or the feces. So those kinds of the process we call the ADAME, or sometimes we call some the TK, toxicokinetic processes. Based on this knowledge, we can define human biomonitoring can be defined as the measurement of chemicals based on ADAME processes. Okay, considering about some the ADAME processes, some tissues or organs can be used for human biomonitoring matrices. For example, I made three different population groups. First one is general population. Yeah, blood is well known and also common matrix to measure any chemicals. And also for the tissue, it can be used, it can be obtained from the operational processes. And also some the fragment to woman, placenta, cord blood, the amniotic fluid. So those kinds of metrics that can be used for to assess the body burden of chemicals. And also finally, some newborn baby. It's if you get some the baby, it's very difficult to hard so how to assess their exposure levels. In recent years, some of the blood spot can be used for chemical measurement because some many instrument sensitivity has been enhanced. So some the small amount of the blood is enough for measurement of the chemicals. So after the metabolism, the chemicals can be depurated from our body. Some excreted fluid like urine, not fluid, hair, anyway, hair, nail, saliva can be used for human biomonitoring, especially for general populations. And also breast milk is a very good medium to represent some contamination status of chemicals, as well as some of the major exposure pathways for the infant. So I will introduce about the meconium with the placenta, which can be utilized for human biomonitoring. So the reason why I'm introducing, so there are so many different types of human biomonitoring matrices. So because if you want to do any human biomonitoring program, you have to utilize a specific mediums with a very suitable or some good research questions. So when you do human biomonitoring, the chemicals can be divided into like this one. Even though this is some my operational definition for the chemicals, so many people are using this kind of some classification. The chemically largely divided into two. First one is organic, the other one is inorganics, including many metals, mercury, lead, and cadmium. So for organic contaminant, the monitoring, the chemicals can be into, depending on their the persistence. Persistent endocrine disrupting chemical, which called the persistent organ pollutant, the POPs. Representative one is dioxin, PCB, DDT, and the others. And also relatively less persistent endocrine disrupting chemicals can be divided into some the bisphenol A groups and the phthalate and paraben, any other some emerging contaminant, the siloxane and the synthetic muscle compound. So when you do study about the chemicals for human biomonitoring, so those kinds of chemicals can be treated as the legacy chemicals. And also our concern is focused on the new emerging chemicals. So some emerging chemicals can be replaced on regulated chemicals or newly synthesized for the replacement of regulated chemicals. So in this presentation, I will talk about there are so many different types of chemicals, but I want to focus on what kind of the matrix is suitable for our human biomonitoring. Okay, so it's very, it looks, the table is very busy. So I made some the different population groups, general population, fragment to woman, newborn baby. For example, if you want to use the blood can show us concurrent exposure levels for certain chemicals. What kind of chemicals? Maybe POPs and metals. However, so if you want to use some the adipose tissue, it is really suitable for POPs study but it is not suitable for less persistent endocrine disrupting chemicals like bisphenols or the phthalate, because the adipose tissue cannot capture some of the less persistent chemicals. Here is urine. Urine is very easy, and also you can collect the large amount of volume. However, it's not suitable for persistent organic pollutant because the POPs can be differentiated from our body through some of the pieces. So like this one, this is just some metrics of characteristics, and also target contaminant. Okay, so with the chemicals. If you choose a serum, your chemical can be limited. It means if you use serum, you can just measure only POPs chemicals, not the others. Some the EDCS chemicals are not suitable for serum. However, if you choose urine samples, maybe urine is suitable for less persistent chemicals based on toxicokinetics or the ADAME processes. And also, serum POPs can be measured using high-resolution gas chromatography. However, urinary-based chemical can be measured by LC-based instrument. What I'm now talking about. So if you choose any chemicals, the chemicals can be detected in specific matrices. If you choose any element, you can make limitations for chemical coverages. So, and also with the sample size as well. For example, some of the serum is a limited sample size is 0.5 to 2 ml. However, some of the newborn baby, we cannot get any blood samples. They don't have any blood lines. So if you want to do any human biomonitoring, you have to consider about what kind of metrics is available. What kind of chemicals do you want to measure? Or what kind of instrument do you have? Or some of the sample size is suitable. There are so many considerations when you do human biomonitoring studies. So this is kind of some the all chemicals covering in my research lab. So I want to show you several findings, the chemicals in the individual human-derived matrices. So first one is a persistent organic pollutant, which is very, very important chemicals, and also the globally regulated chemicals like dioxin and PCB. And also recently, PFAS is very, very important chemicals anywhere. And also the PFAS can be treated as a forever chemicals. It cannot be degraded. When you watch some of those kinds of figures, so this is a black circle means some the detection rate. The right-hand side, it means some the people's PFOA, PFNA, PFHS were detected in all serum samples. And also some the bar graph means some of the detected concentrations. Anyway, so PFAS, organochlorine pesticide, PCBs and PBDs were detectable in Korean general populations. And also we can get good information about exposure levels of targeted chemicals if we use some of the serum samples, even though sometimes the serum is not invasive, we need invasive sampling protocols. Okay, let's move on to the breast milk. So breast milk can be used very common metrics for global monitoring program. United Nations Environment Program are conducting milk monitoring for measuring POPs and emerging contaminants around the world. We joined this program, and also we found some of the PCB, organofluorine pesticide, the brominated flame retardant, PFAS as well, and also new emerging chemicals like a synthetic muscle compound, benzo triazole UV stabilizer. Those kinds of chemicals were detected in our breast milk samples. If you use breast milk samples, you can do health risk assessment with a comparison of the threshold values proposed by some international authorities or some domestic authorities. For example, some that we collected, yes, the breast milk is good medium to represent moderate exposure levels, and also very unique exposure pathway for newborn infant from mothers. So it means some the concentration in breast milk means some the exposure levels for infant. And we measured some those kind of chemicals, and we compared some threshold values proposed by international authorities as well as some domestic authorities. So it's very interesting and also very surprising. Even though PCB and organochlorine pesticide completely banned 60 to maybe 50 to the 60 years ago, however, that chemical was still detected in breast milk. It means mothers are already exposed to their bodies, and the chemicals are transferring from mother to their babies by lactational activities. And also, so those kinds of synthetic musk compounds newly uh, introduced in our scientific society, which can be used for cosmetics and hand cream. So it was also, yeah, some their detected levels exceeded some the threshold values. It means that our infant is not so safe, I think. So it means some together with all findings for breast milk, we can do human biomonitoring and infant exposure assessment as well as human risk assessment as well. So I'm talking about the placenta. So placenta is can provide the possibility of a placental transfer, exposure of the unborn child. So I think this is also some the non-invasive metrics is for PAPS measurement. It was already published in the Stoten. So placenta is a very good medium to represent the mother's exposure levels. Here is some of the maternal blood. And also we measure some of the cord blood. Cord blood, we think some of the cord blood means the half is from mothers, half is to belong to the babies. It means the placenta can provide mother's exposure levels as well as some of the infant exposure levels. And also this is non-invasive. So placenta can be utilized for persistent organic pollutant monitoring. We already discussed about this, my research project with Hyo and others on the friend. So we got some the placenta samples from Antarctic, yeah, to measure certain chemicals using non-target analysis. And I want to look for what kind of chemicals are detecting in the placenta from the Antarctic seal samples, and also which can be implied for long-range transportable as well as next generational, yeah, transfer from mother to their babies. So we can suggest some the strong regulation on the detected chemicals in placenta, yeah, from the Antarctic seals. And also we measured some chemicals in meconium. Meconium is the first feces after born, which can provide historical overview of exposure during, yeah, some mothers inside, easy to collect exposure of unborn child. So we can find out a very good significant relationship between the cord blood and meconium, and also some maternal blood of meconium. So I think this is very interesting. Meconium is the first feces. It means it can reflect some of the mother's body's environment. So if you use some meconium, you can expect what kind of chemicals are transferring from mother to their babies. I think sometimes some of the placenta samples, even though the chemicals can be detected in placenta, but the placenta is just the existence of chemicals in placenta. We cannot guarantee some of the chemicals are transferred to their babies. However, meconium means already originated from infant. It means that it was really transferred from their mothers or mother's environment during pregnancy. Okay, hair, we tried to measure some chemicals in hairs and the flame retardant, the PBD, organ phosphate flame retardant, and noble bromine flame retardant. And also you found some the serum concentration and hair concentration were significantly matched with both. So it means some the hair can be used for excreted chemical exposure levels for certain chemicals. Okay, I want to move to some the urinary chemicals, the urine samples. So we measured many different types of chemicals using the urines, yeah, obtained from Korean women, and also it was already published in several papers. So this is some the child varying ages, some the 25 to 45 years. We collected from Seoul and other cities. And also you found the Hyo-Bang, the phthalate metabolite, and the benzophenone, triclosan, and the bisphenols. So we concluded some the woman's health is very important for if you consider about some the next generation health. So but it was already exposed to many different types of chemicals, and also we collected some the urine samples from the Korean children. Some samples were well matched with the mothers and urine, almost the same contaminant profiles were observed between mothers and their babies. It means that you are now facing very similar environment for chemical exposure, for some the mother and their babies. So now I'm now talking about the urine. So and also I'd like to move to the next subject of this presentation, like the representativeness of the urine samples. Okay, many people are thinking about when you do human biomonitoring, especially environmental health scientists. I'm doing human biomonitoring. Okay, you are using urine samples for chemical measurement. Yeah, so I joined the urinary biomonitoring. However, I found the urine samples, even though the urine sample has a good advantages, like some the common metrics of human biomonitoring studies, and also the less persistent compound is very really suitable for those kind of chemical groups. And also some of the recent exposure, yes, very easy, non-invasive, and also we can obtain the enough sample volume. However, if you can this graph, what do you think about that? We collected all urine samples from one guy. So the chemical concentration, MMBP is metabolite of some the phthalate. Their concentration changed into within a day and also between day and between or within a week. So their concentration fluctuated. And also if you collect this time and also this time, they showed us the big ranges or big the variability. So even though the urine samples can have good advantages, however, I have very skeptical insight for urine samples because they are not representative sometimes. So we made the good study design to overcome this issue or to assess representativeness of the urine samples to support the comprehensive human biomonitoring study. So I think I needed to explain about what kind of chemicals were studied in my research project. This is a phthalate. This is representative plasticizers applied for industrial product, medicals, devices, as well as some consumer product. DEHP is a representative phthalate chemicals. So we have many exposure pathways, some the food intake, some contact with some product, and also use some the cosmetics. Yeah, in our ingestion, thermal, and also some the inhalation can provide us some the major exposure pathway to humans. However, phthalate is very easily light to express some their exposure levels. So based on the chemical toxicity, yeah. So phthalate has been regulated from many different types of some international authorities. So after use for the PVC, yeah, with the phthalate, it was regulated in 1999, firstly in European countries, and then Japanese government joined to control the use of some phthalate in children's toys, and Korea is and also made some restriction to use some selected phthalate in children's articles. And then some countries and some international authorities are regulating the use of the phthalate. So industry want to make the replacement of regulated phthalate. Right? We call the alternatives of phthalate. Big problem. This is the use and passage of phthalate. So phthalate is not our one chemical or single chemical. Many people are thinking about the phthalate is TEHP. TEHP is just one of phthalate. TEHP were usually used for some the PVC product. However, DMP-TEP, which is the lower molecular weight, can be used for cosmetics or daily the consumer product. So the medium size, the medium molecular weight size, the chemicals can be used in different applications. So different use can result in the different pathways. So the cosmetics, it can be, you can expect some the thermal exposure of phthalate. However, product may be some the direct ingestion to the contact or hand to mouth habit. Sometimes food package is ingestion is a major exposure pathway. I think phthalate is very tricky to control, to regulate, because they can show us different applications as well as depending on some of their the exposure pathways. So to assess some this issue, we made good study designs. We collected all urine samples from 12 Koreans over 1 week, 7 days, to assess some limitation to the investigate the limitation utility of spot urine samples. And also you are tried to track the exposure sources based on some of the all the samples, all urine samples. And also we assess the within and between individual variability of a metabolite. And also we investigated some of the feasibility of the first morning void. So we recruited some the 7 females and 5 males, different age and different job and the different locations for their residence in 2016. And also we obtained some of the questionnaire, some of the investigating for their lifestyle and living environment. And also during the 7 days, we got all information from the all participants. So, for example, what they eat and what they do and what they use. So like cosmetics, everything. So it's very, very some thorough, very tough work. And we use some the KakaoTalk to receive all information from all participants. And also we tried to analyze some of the phthalate and other chemicals. Today I just focus on the phthalate. Okay, so what do you think about this figure? It looks very busy. I think so. Yeah, this is the male 1, male 2, male 3, 4, 5. This is the different chemicals. That really fluctuated. Sometimes within a day, sometimes within a week. Yeah, this chemical only detected high only day 5. So it's very, very tricky, I think. And also the female. Yeah. Some ladies is very, very low exposure level for phthalate. But the female 6 is the day 2 is the highest, showed us the highest peak for phthalate. What happened to this lady? Yeah, so maybe we are already published many one using this data set. They use some of the cosmetics and they use the pharmaceuticals. After then, their concentration rapidly increased. However, so if so, you are thinking about sampling time point is very important. Sometimes after wake up or before sleep or sometimes after meal, which one is representativeness? It's very, very challenging for us. But many the environmental health scientists, they when they collect the urine samples, okay, it's okay, it's okay. Yeah, encouragement of sample number is more important. I don't think so. Yeah, after getting all information, we can give us some good insight. So to assess some, representativeness of the urine samples, we used the intra-class correlation coefficient. This is one guy, their concentration showed this ranges for certain chemical, MEHP. This guy is this one. But okay, so when you do some association studies for environmental epidemiology, okay, the highest levels were detected in certain guys. If so, maybe they can show us any the health outcome. Okay, this chemical exposed is associated with this health outcome. This is some the reasonable epidemiological studies. However, this urine sample can show completely different chemical ranges. And also, so we are considering about the within person and between person, which one is more so larger. Yeah, so like so we employ just ICC. ICC's function can be like this one. B means, yeah, sigma square. B means the between person variance. Yeah, W means the within person variances. It means higher ICC means that they can show us the between person variances. Low ICCs, so all individuals have very similar exposure levels. I can show you the one figure. This is a 7-day urinary phthalate for MEP. So normally MEP was originated from the use of cosmetics or consumer product. So we compare the spot urine. Spot urine is the randomly collected all urines, and the FMV means first morning void. After wake up, you collected the first, the urine is we define the first morning void. Some younger generation to wake up on the 1 p.m. So it's okay. This is also on the FMB. But some the older ladies, yeah, some the wake up almost on the 4 a.m. Yeah, for praying in the church. So this is also FMB. Yeah, we are considering some the metabolism during their sleep. So, and also composite samples, we pooled all samples with a consideration of some urinary volume, and we made one samples. What do you think about this one? For example, M2, this is a range of all sponge urine. However, if you use some FMB, yeah, the concentration range was smaller, yeah, minimized, and also some the composite is very similar to this one. So we calculated some of for all phthalate metabolite, yeah, ICCs. We can calculate ICCs for all the phthalate metabolite. All sponge urine. I think this is not reliable to show us a representativeness. However, some MEP is relatively the representative because MEP is originated from the use of cosmetic. If I use just the one cosmetic, this is a distinct exposure sources between other person, because I just use this cosmetics, but the other lady, the other guys just use this hand cream. Yeah, there also chemical exposure profile is not changing during a week. However, MEHP, MEHHP, those kind of chemicals, DEHP metabolite. DEHP are originated from all available contaminant sources like food, dust, and water, yeah, air. So they can show us very, very low ICC. It means they are not distinct between persons. However, if you use some daily composite, ICC coefficient increased after using the daily composite. It means spot urine is not reliable for human biomonitoring. If we want to do any human biomonitoring, or the spot urine is randomly collected spot urine is not reliable. It is not representative to show us some of their exposure levels or exposure sources, any other things. So I can show you some the DEHP metabolite. Okay, DEHP can be metabolized to MEHP. This is a person metabolite, and MECCP is a representative second metabolite. They can show completely different patterns, but MEHP is really, really difficult to find out in urine samples because their first metabolism is a very short time. MEHP half-life is less than 1 hour or 2 hours. It means some of the MEHP is not good the bioindicator for human biomonitoring. However, some of the other second metabolite is relatively conservative, and there some ICCs increased after using some of the daily composites. And also we considered about some the all our the statistical approach is use some unadjusted. It means the real samples, for example, like this one. However, if you go to the toilet, you can see the urine the color. sometimes very yellow, sometimes very like some clean. This is the difference is because of some the creatinine concentration. So we adjusted some the creatinine concentration, their ICCs increased, like this one. And also the specific gravity also the adjusted for the unadjusted all span urine is the ICC coefficient some the increased, which means if you just use the random samples, the urine or n unadjusted the concentration for certain chemical, it was not so good choice for your human biomonitoring studies. This is I just want to show you some the visualize for unadjusted creatinine, adjusted SG, specific gravity adjusted. The ICCs is increased. So when you do any human biomonitoring, you need some the other creatinine adjusted or the specific gravity adjusted concentration for chemicals. And also we compared some of our data set for pulse morning void and daily composite. We found some of the really significant correlation between pulse morning void concentration for chemicals and the daily composite. Daily composite is really reliable samples because some of the we pulled all whole day samples for per day. It means that they can show us some of the time integrated exposure levels in exposure history. So FMB is a well reflect some the history of some the exposure levels and exposure origins. So if you do not have enough time, if you do not have some like some the enough research fund, I think the pulse morning void is a good choice for human biomonitoring instead of some daily composite is very really tough. You have to ask to all the participants. You have to pull all your urine samples is impossible, I think. Okay, so the many people are thinking about how to track the contamination sources of the phthalate. It's very commonly used in our surrounding environment. So, however, so for the lower molecular weight phthalate MEP, you can see here you found a very highest peak, and then you compared some the what they did, and then based on the questionnaire survey, she used no, sorry, male, he used the perfume. And then their concern urinary after use of the perfume, the urinary MEP concentration rapidly increased. And the use of the shampoo, body cleanser, shaving, I think he got the shower. After shower, some of their concentration increased. Yeah, when you do go to the toilet. So it means some of the use of the cosmetics and the personal care product can make higher exposure of only MEP. However, what do you think about the DEHP? Even though we tried to match what they did, what they eat, and also what they use any cosmetic personal product, I cannot find out the suitable sources. I think the DEHP is commonly used food, drugs, and also dust, air, water to many sources. Really ubiquitous. However, some of the major phthalate is DEHP. So this is some of the DEHP metabolism. DEHP can be changed into MHP. This is first hydrolytic the monoester. MHP first trim metabolite, and also second metabolite. Unlike some of the other second metabolite like this one, the MEHP can show us good information on what was exposed. It means some of the MEHP is very short half-life in our body. However, if they can show us a highest peak, high concentration, maybe they did something. For example, some of the cup noodle. After eating cup noodle, yeah, you can find some of the MEHP. And also those kinds of some of the we called some Korean style rice, some of the like this one. Packing so and then I don't know some English name. This is some rice burger. We call it the rice burger. So we measured some this rice, but the DEHP was not detected. However, packing material showed a really extremely high concentration. So I think some of the food packing material can be used for some of the DEHP and other some of the plasticizers. So I think some of the MEHP can be used for source tracking, even though it was not suitable for human biomonitoring. It was not time integrated, but prompt expose indication. This is very important as information. Okay, so together with some all my the talk, so I'd like to summarize. Okay, so in this presentation, I touched with the representative list of the spot urine samples, and also lower molecular weight phthalates could be tractable, for their sources with the spot urine. However, the higher molecular weight phthalate had a limitation on their source tracking. MEHP, which is the first metabolite of DEHP, was suggested as the biomarker of source tracker for DEHP, even though which was not suitable for the human biomonitoring. It's not too fast, rapidly excreted from our body. NMW phthalate had a higher ICC than HMW due to the presence of specific sources. Creatinine and the specific gravity should be considered for adjusting urinary phthalate concentration, which can provide us a comprehensive human biomonitoring. First morning void was suggested as a practical and cost-effective than collecting random spot samples, because the composite sample is impossible when you do when you want to increase the sample numbers. Okay, so thank you very much for your listening. I'd like to add one more slide to advertise the upcoming international conference. Yeah, the 11th International Symposium on Flame Retardant, so we call the BFR 2024, which will be held in Incheon. This is the host organization, the Korea POPs Forum, we call the K-pop. I'm now the charging in some the president of the K-pop. Yeah, so if you want to hear some my songs, I can show you. Yeah, so I'm now taking some the symposium chair. So in April is very nice weather in Korea. So please come to Korea. Thank you very much for your listening.
Thank you, Prof. Moon, for the insight talk. Now we open for the question. I think maybe from the participant online.
I think you want to.
Yeah.
One question, and I'm very interested in what you shared with us just now, especially some of the levels of things. When you measured for example, one of the participants in which you measured, if I'm not mistaken, the low molecular phthalates, this one after perfume and after shower. So I would like to know, is it frequent for many cosmetics providers or manufacturers? Is it frequent for them to actually do this kind of testing before they actually launch their products, or they just do a normal clinical trials maybe on animals without actually looking for them to this kind of test? And if they did actually use this one, or maybe if you have any data related to these products, maybe you can suggest some of the safest products for us to use. Yeah, because we really don't know, because we just use, for example, we have many brands coming from any part of the world, so we just use anything without knowing the effects. We just know that it is clinically tested, but then we need to know this kind.
Okay. Okay, thank you very much for your question. I think some online people cannot hear his question. I think his question is about some how to conduct to avoid some the chemical exposure from the product. Yeah. Okay, so the first one, you have to ask what kind of chemicals were used in product, and then it means and then you can choose the product. This is the first the ask to industry, because the customer can change some industrial people. Government cannot change industrial people. Yeah, for my personal feeling. Yeah. Second one, if you know about how much chemical will use in product, you have to choose some the more safe chemical, more safe product. Yeah, this is the second one. And the next one is however, so even though some you are doing those kind of some activity, some unknown chemical can be used in product. I know many experiences. I have many experiences, and also I know many secret chemicals. Sometimes very toxic. It means okay, this is eco-friendly product, eco-friendly cosmetic. I found the highest, extremely higher levels of emerging contaminant because some industry want to escape regulation. Industry want to change from regulated chemicals and then the use of replacement. However, the replacement is sometimes a regrettable substitute. It means that it is also some very toxic. So you need some another challenges. I think, for example, you have to ask to regulate some chemicals, yeah, to the government, and also you have to ask some the class-based regulation. For example, BPA, bisphenol A, is very toxic chemical. So government is regulating BPA. The replacement was BPS, BPP, BPF, bisphenol series. We call the bisphenol analogs. So now we are just all the regulatory action is focused on individual single chemical. However, if you found any problem from BPA, you have to regulate class-based bisphenol analogs together. I think this is a very reasonable regulatory action program. Otherwise, you can get some more experiences from another replacement, which are still very toxic chemicals. So many countries are trying to this concept for apply for their regulatory programs. For example, organochlorine pesticide together with all OSHIP organochlorine pesticide, and also bisphenol analogs, fluorinated chemicals, brominated chemicals. So this is some the activities from scientific part, I think. Yeah. So, and also, if possible, do not use some the cosmetic and any other personal care product, if possible. Yeah, I'm trying to. Yeah. Okay, so yeah. So her question is about what kind of some material they will use for packing material in Korea. It depends on some individuals of the stores, I think, but they use some aluminum foil. So I'm now using aluminum foil for my experiment, but people use I'm washing all aluminum foils because it was very contaminated by other chemicals. Yeah, so I need to wash. It means some many chemicals are already used in the packing materials. So during COVID-19, many publications on the food packing materials, because some in Korea, for example, in Korea, we cannot go out, so we ordered many some the delivery food. Yeah, it means some during COVID-19 our exposure level increased because you use some the delivery food with the packing materials. Yeah, it's especially some the DEHP. So now some companies are developing some the replacement of some very toxic packing materials. Yeah, to change the other one, I think. So let me check some the Malaysian some food packing material. That's a good idea, I think. Yeah.
I think they
One question from the online participant. Previously, Prof Moon stated that breast milk is one of the pollutant. So, in your opinion, do you prefer milk from the store or breast milk is the best for the baby?
Okay. What I'm doing now? Okay, thank you very much for your question. I asked my wife, yeah, to give breast milk to my baby. Yeah, so we need to make a balance. I just focused on the toxicity of breast milk. because I found many chemicals in breast milk. However, breast milk also contained very beneficial component for babies. So we need some of the risk and benefit. We need to make a balanced studies. So very similar studies were conducted by myself, seafood. All kinds of chemicals are in seafood. However, seafood also contain good, beneficial component like unsaturated fatty acid, omega-3, and also some of the EPA, DHA, something like that. Very interesting finding. High levels of unsaturated fatty acid was also well correlated with high levels of persistent organic pollutant because POPs are soluble in fat. What do you think about that? The best way is, okay, so you can consume, you can eat seafood without chemicals. That's a the fundamental way is to remove chemicals from terrestrial environment, not to release to marine environment. However, I think it's impossible because the chemical can be biomagnified through the food web. So if you use some of the tuna, some of the salmon, it's extremely higher levels of the chemicals. Breast milk is also a very similar situation. In Japan, Japanese mother does not provide the first breast milk to their infant. They know about the first milk was highly contaminated by dioxin. In Japan, some of the all wastes was incinerated. It means the combustion processes, combustion process treating. So the high levels of dioxin was contaminated in first breast milk. However, so we compared their concentration first day, second day, 1 week, and up to 1 year, so meaning that 12 months, the concentration decreased after releasing some of the breast milk. However, instead of some declining of some the persistent organic pollutant originated from mothers, the other chemical increased, like some cosmetics and the phthalate and others. If you have any experience to give a baby, so the first time, maybe they are very cautionary to use any product, first month, second month. However, after months, some the mothers want to use cosmetics. They want to eat some food. It means another exposed pathways increased. So my suggestion is, the level is very important to one. The level means the contaminant level is very important for their baby. I think the first maybe within 2 weeks, breast milk is sometimes very dangerous. However, after 2 weeks, some the breast milk the safer than some the infant. In Korea, traditionally, all mothers asked the first breast milk should give their baby. This is our tradition. So I think we need to make a balance. So maybe, and also at least so government should offer some data. What kind of chemicals contained in breast milk, and what kind of good component in breast milk, and individually some the mothers should decide. Okay, this is good for my baby. Like this one. It's very it's a hard question for me. We are now ongoing. Thank you for your question.
I think they also ask, does gender play a significant role in cell metabolism?
Yes, I think so. Thank you for your question. I have many concerns on the women's health, because when you talk about the chemical exposure, chemical toxicity, the major toxicity should be reproductive failure. The wildlife studies for me, so I'm doing study about the marine mammals. The marine mammal, what kind of chemical is very dangerous for them? If any chemicals can make a reproductive failure, their population could be declined. Like similar to the marine mammal, for human, women's health effect is very dangerous, because women's body are related with their next generation, their babies. So phthalate is very dangerous for women, but however, it's very interesting. Phthalate is very dangerous for men, especially, particularly, especially for the salmon quality. Yeah, salmon quality. It means so it also can result in some the reproductive failure actually. Yeah, so as I know, there are so many chemicals show us some the significant difference in depending on sex. The phthalate is very clear, significant some the metabolism for male and females, I think. A link, please. How can I do? It's okay and not dangerous. Oh, no, this one. Oh, okay.
I think if there's no other question,
Attendance.
maybe we end the session for today now. Once again, on behalf of Immb, I would like to thank Prof. Moon for the insight talk and the very interesting talk that you delivered today. Okay, thank you, Prof.
Thank you very much for listening.